Have you ever tried to take a picture of something really tiny, like a dust floating in the air? Now imagine trying to figure out exactly where the tiny piece of dust is, and also how fast it's moving at the same time. Sounds easy, right? Well, not in the microscopic world. And this is where one of the most misunderstood ideas in science comes in: Heisenberg uncertainty principle. A lot of people think that this uncertainty principle means your tool aren't good enough or the measurement is not precise. But no, that's not it. In the quantum world, nature itself refuses to let you know both the exact position and exact momentum of a particle at the same time. Not because your tools are bad, but because that's how reality works, on the smallest scale. Let's break this down with something more familiar. Imagine you're looking at a tiny dust particle under a microscope. If you use very soft, low energy light, the dust barely gets disturbed. That's good because you can watch how it moves. But the problem is that soft light does not give a sharp image. The dust looks fuzzy and its position becomes uncertain. Now let's crank up the light. Shorter wavelengths, brighter beam, lots of energy firing at the dust. Suddenly, the dust appears super sharp, great. Now you can tell exactly where it is. But then something else happens. Those energetic light particles smack into the dust like tiny like billiard balls and it push around. So sure you know where it's right now, but you just scramble its motion and its momentum is now uncertain. That's the heart of the uncertainty principle. When you tighten the knowledge about one property, position, nature forces the other property, momentum, to loosen. And no, this isn't about having a bad microscope. Even with the perfect one, this trade off would still happen. Everything at a tiny scale, atoms, electrons, molecules, behave not like solid like little balls, but like waves. And the waves simply cannot be both perfectly located and perfectly non-spread out. If you squeeze the wave tightly into one spot, it spreads out its momentum. If you let it stretch smoothly, its position becomes fuzzy. This is not a flow, this is physics. And because of the uncertainty principle, atoms do not collapse into their nuclei. Electrons naturally spread out in a cloud instead of falling into the center, and the matter, including you, is stable. So yes, this is tiny rule from quantum physics literally holds up the structure of the entire universe.